The question is to solve for the natural number k's values. Every single natural number values k when the quadratic function y is equal to x squared minus 4x plus k minus 2's vertex is on the fourth quadrant on the coordinate plane. So this question is basically asking to solve for the every single natural number, in this case k, which is going to change the location of the vertex of the quadratic function. And the quadratic function in this case will going to be y is equal to x squared minus 4x plus k minus 2. Therefore, we have four solutions to approach these questions. Firstly, we need to think about what is the vertex, which will going to be our first solutions to approach this question. And we need to think about the definition as well as types of our vertex, but the definition can be defined through the types of it. So luckily they're all defined by the leading coefficient A. And if you don't know what the leading coefficient will look like, we can go back to our original standard form, which is the basic format of our quadratic function. First thing that we need to talk about in order to approach this question will going to be the standard form. And as we can see, standard form will going to be the most basic format in the quadratic function. If you don't know what it contains, it will going to be y is equal to ax squared plus bx plus c. And from here, let's think about what this its variable does in the standard form, or what does its variable defines. So the first thing that we need to talk about will going to be y and x, obviously, because every single function contains y and x. Y value will going to be a output of our function. X value will going to be an input where we input some specific values to our original function, which we're going to be make, which will define our function. And the second thing that we need to talk about will going to be the most important thing in the standard form, A. A will going to be our leading coefficient. The leading coefficient. And we know that coefficient is just a numbers beside variables. And the difference between the leading coefficient and just a coefficient will going to be defined by the word leading. And if you don't know what the leading means, it is a short word for him to refer to our highest degree power term in the quadratic function, which will going to be x squared. X squared will going to be a leading highest power term, and the coefficient of the leading term will going to be a. And the reason why the a is important is because it is a thing that defines our types, as well as the definition of our vertex in the quadratic function. This is what the a means, and we can talk about it more specifically later. And the second thing we're going to be b. B is exactly the same concept with the a, except it is just a coefficient of the first degree power term x. Now let's think about the last one, which will going to be c. C will going to be our y-intercept. And if you don't know what the y-intercept means, if we convert into some specific coordinate of the function, it will going to be when the input of our function is equal to 0, our output will going to be y. This is what the y-intercept will going to be. So these three things, C, B, and A, which is the most important thing in the quadratic function that occurs all the time and defines its things. More specific, let's think about our types of our vertex through our A. So the first case of our, the second one, we're going to be the types as well as the vertex. The definition of the vertex. So they're all defined by our leading coefficient of a quadratic function A. In the first case, types of our vertex will operate when our a value, our leading coefficient, is greater than 0, which means when it is a positive value, the graph of our quadratic function will opens upward. And when the quadratic function's graph opens upward, for example, it will look something like this that keeps going toward upward and contain most important point in the quadratic function, which will going to be its minimum, or we call it as the lowest point on our quadratic function too. And this will occur when our a value is greater than 0 and the graph goes upward. And the second case of our quadratic function, the second case of our quadratic function will occur when our a value is less than 0, which means when our leading coefficient is negative, the graph of our quadratic function will open downward, unlike the first one which opens upward. Which means it should always be opposite with the first case, which means it will go downward. That will look something like this that keeps going toward downward and never intersects at one point. But then it will going to contain another most important point in the quadratic function, the maximum point, or also we call it as the highest point on our graph. And these things will occur by our a value sign. And from here we can think about the definition of our vertex. The definition of the vertex is same thing with the addition between the number of possibilities between the minimum point and the maximum point. And it will going to give our vertex. And as we can see, they will going to be all defined by our a, our leading coefficient, our quadratic function sign. So from here, which means the types of our graph, to the definition of our function, they were our first solutions to approach this question, which means we are talking about the types as well as the definition of the vertex. So we need to talk about the second one, which we're going to be the general the three types of general quadratic function forms. So our third word, which we're going to be the second solution to approach this question, we're going to be the three types. So we're going to be the three types of quadratic function forms. So for three types of quadratic function forms, there are standard form, binomial form, and lastly, there were a vertex form. Let's think about what each functions form was optimized. Firstly, the standard form, which is the basic format of the quadratic function y is equal to x squared plus bx plus c. It is optimized for the easy calculations for solving for the variables, the unknown variables. And also, it is optimized when it comes to solving for the y-intercept. This is a property of our standard form. But one thing that is bad about our standard form is we cannot draw a perfect problem of a quadratic function because we can't solve for a vertex. And we know that vertex, every single coordinate in our coordinate plane is formed by x, y, where x is equal to input of our function, and our y value is equal to the output of specific function. And for the standard form, there is no way to solve for our vertex. So that means we won't be able to solve for or draw our perfect format of our quadratic functions problem. Secondly, let's think about the binomial form, which will going to be our second format of our quadratic functions form. So its formula is y is equal to a times x minus p times x minus e. And if you think about what it is optimized for, it is optimized when it comes to solving for the x-intercepts. So it is optimized for solving for the x-intercepts because it is formed by the x-intercept. And also, the one thing that is convenient about our binomial form is we can draw a perfect format of a parabola without converting this into some specific format. The reason is because we know the vertex is formed by x, comma, y. And for that x value, which will going to be our input of our function, that input we're going to be mean over the average. So we're going to be mean over the average is the same meaning of 2x intercepts. So if you simply add up the 2x intercepts and divide it by 2, which we're going to give us the input or x value of our parabola's vertex. So we'll be able to solve for a full vertex, which we're going to give us a parabola format. And we can solve for it without converting this into some specific format. And the last thing about our last format will going to be our vertex form. We can see from its name, vertex form is optimized for solving for the vertex of a specific function, which means it is the most easiest form for solving for the vertex as well as graphing the parabola. The reason is because the p value will going to be the x-coordinate of vertex, and the q value, which will going to be our constant in this case, will going to be our y value, our y-coordinate of our vertex. So using this two information, we'll be able to solve for our vertex easily, which will going to give us the full graph of our parabola. And these are the three functions format: standard form, binomial form, as well as vertex form we talked about its properties. And these things will going to be our second solutions, which will going to be general three types of quadratic functions forms. Let's think about the properties of each quadrant in the coordinate plane. And there always should be the x and the y-axis in the coordinate plane. And the order of the coordinate plane will going to be the first quadrant, the second quadrant, the third quadrant, and the fourth quadrant. And let's think about the signs of each quadrant's x and the y signs. So for the first quadrant, as we can see, the x value is equal to the positive value. So the x is equal to positive. And also the y value, which will going to be the output of a function, will also going to be a positive value. So this will going to be a x and a y signs in the first quadrant. Now let's think about the second quadrant. As we can see, x is on the negative quadrant, negative sign, so the x value will going to be the negative value. But the y value, y-axis is exactly the same, which means the y-coordinate should always be the positive in the second quadrant. And for the third quadrant, x is negative and the y should also be negative. So when the x, our input, is equal to negative, our y, our output of our function, should always be the negative too. Let's think about the last quadrant, which will going to be the fourth quadrant. When the y value is negative, our x value will going to be a positive. When the x is equal to positive, our y value should also be a negative. So from here, we thought about the fourth quadrant, 1, 2, 3, 4, and we talked about its variable signs as the properties of each quadrant. And this was the third solutions to approach these questions. And we have the last one, which we're going to be the 4 types of constants in the quadratic function that we use. Lastly, let's think about the last solutions to approach this question, 4 types of constants in the quadratic function. And if you think about what the constant means, it is every kind of numbers that doesn't change, unlike the variables. So there are 4 types of constants. So there are 4 types of constants that we used in the quadratic function. These were going to be the constant, which is just a number. It can be every single numbers, including decimal fractions or just natural numbers. And the second case that we use in the types of our constants we're going to be integer. And the integer is a little bit different with the constant. Integer will going to be a natural number. We're going to be a natural number, but a little bit different with just a natural number. It includes both positive as well as the negative natural numbers. This is what the integer will going to be. And the third case that we use for the constants, we're going to be a natural number that is related to the integer. So the natural number. Natural number is same thing as 1, 2, 3, and on and on and on, except for the decimal or fractions. And also, if you just count these numbers as n, those natural numbers should always be greater than 0. It can't be 0 or negative. This is what the natural number is. Lastly, the coefficient that we talked about in the last part. Coefficient means it can be anything. It is a constant basically, but the constant, but that difference is constant beside. So it is a constant beside variables. An example of variables are going to be x or y. So these are the 4 types that we use as the constant. And this was the last solutions to approach these questions. 4 types of constant in the quadratic function. So let's make a line to divide these lines. Now let's actually approach this question. Back to our original question is that the k value, our ultimate goal is to solve for k. It is a natural number, which means it should be a integer except it is a positive and greater than 0. So the k value should always be greater than 0. This is one information. And the second information is that we need to think about the vertex of this function, because we need to make the k value to change the location of the vertex to the 4th quadrant. And if you think about what the 4th quadrant was, the 4th quadrant was when the x value is positive, our y value should always be negative. When our input is positive, our output is negative. This is our second properties or information that are given. So first of all, let's think about our vertex of our quadratic function. Y is equal to x squared minus 4x plus k minus 2. In this video, we're talking about the easiest way, the fastest way to solve this question. And the way to do it is to apply our formula. It was also a good situation where we need to convert this into vertex form, but it was going to take us a long time. And the formula for this was negative b over 2a. So if you apply negative b over 2a to our original function, we're going to get 4 over our negative 2, so 2, which will going to give us 2. But this one, the formula is to solve for our x coordinate of our vertex, which means our 2 we're going to be our vertex x. So our output left, all you have to do in order to solve for output is input our x, and it will going to generate our output, which we call it as the y value. But if you input our 2 value here, we're going to get y is equal to 2 squared minus 8 plus k minus 2. So if you simplify this, we're going to get 4 minus 8 minus 2 plus k, which will going to be minus 6 over k minus 6. So k minus 6 will going to be our y coordinate. So we're going to be our y coordinate of vertex, but it includes specific variable. So we can write our full vertex down. Our full vertex was 2 comma k minus 6. And let's go back to our second information. And it says it should be on the 4th quadrant, where x should be positive. So the x should always be greater than 0. Let's actually compare it. Our x value, which in this case 2, should always be greater than 0. It is a true statement. Now let's go back to our second one, k minus 6, which is a y coordinate of vertex. Our y value in our 4th quadrant should always be less than 0, which means it should be a negative value. That is same thing with this one. Our y value is k minus 6, and that should be less than 0. And all you have to do in order to isolate our k value, which is our ultimate goal to solve for our k value, all you have to do is add 6 to the both sides. To isolate, we get k should be less than 6. But the k should always be a natural number. Natural number, which means if you think about the properties of a natural number, so n should always be greater than 0. So that means k should be greater than 0. So the k value in this case will going to be 1, 2, 3, 4, 5. And this will going to make our vertex in the 4th quadrant. So our answer for this question for our k value, there were totally 5 k values total. 1, 2, 3, 4, as well as 5. So let's review what we did here. Firstly, we talked about the 4 solutions in order to approach our question, and ultimate our answer was solving for a k value, or a k value for that makes our vertex of our function y is equal to x squared minus 4x plus k minus 2 into the 4th quadrant. So we thought about the first one, types of definition of vertex in the function, as well as the standard form. Secondly, we talked about 3 types of function forms and its properties. What is it optimized for? Thirdly, we talked about the quadrant, which is the most important thing, I guess, in this question. It's signs of x and y variables. And the last one was 4 types of constants in the quadratic function, differences between its constants. So we approached our question and we actually solved our question. And lastly, we got our k minus 6, which will going to be our y coordinate of our vertex should always be less than 0. Since we knew that our coordinate of our 4th quadrant, x should always be positive, y should always be negative. So we isolate our k term. K should always be less than 6, but also it is a natural number. It can't be 0. It can't be negative. So our total k value was 1, 2, 3, 45, which means there were total 5 k values for these questions.